Welcome everyone. This is the Cove Data Protection Continuity Services Bootcamp. My name is Eric Harless. I am your head backup nerd here at Enable. As we go through the session today, there are some features and functions that are currently being developed as part of our roadmap. The various questions that we come up with also may lead me into discussions around features or functions that have not yet been made generally available inside of the product. When presented with those type of questions and inquiries, I'll do my best to preface anything that is not generally available as forward-looking. Please don't make any licensing or purchasing decisions based on features or functionality that has not yet been released as generally available. That could include items in a feature preview, in an alpha, beta, or engineering preview state. Like I said, I'll do my best to preface that when we're talking about things that have been considered or maybe on a short-term or long-term style of roadmap, okay? So for those of you that I have not met before, my name is Eric Harless. I'm the head backup nerd here at Enable. Yeah, that is my title. I've been with the organization now working on the Enable backup products for right at 10 years. It'll be 10 years here in another 4 days. But a little over 25 years in backup and data recovery. Various vendors you may have grown to love or hate previously, so I won't do any name drops this time around. If you want to talk about that one, though, definitely reach out to me. We'll have a laugh at where some of these vendors have went and gone or been acquired by. It's been a mixture of roles: sales, support, system engineering, product management, predominantly product management. My first 6 years here at Enable in product management, focusing on the Cove product. My last 4 years now in this head nerd role, focusing on building out, growing a community around Cove Data Protection, training, education, scripting, automation, best practices, those kind of things. If you want to reach out to me on email, social media, on various platforms out there, you can do that. My email address is eric.harless@n-able.com. My Twitter or my X handle now is @backup_nerd. You can also hit me on Facebook groups. You can find me on Reddit. You can find me on some of the various Slack channels. So lots of different ways to interact. You can also reach out to me directly and schedule a one-on-one nerd call through a Calendly link. There is a handout document in the handout section of GoToWebinar. Grab that. It'll have all of the links, my social media handles, how to get to our blogs, upcoming events, support sites, documentation sites, things of that nature. Any of the URLs I'm going to talk about or show today during the session are available in that handout document. So go ahead and take a moment now and download that. If you did download it previously, either last year or earlier this year, there are a few additions to it, so you might as well grab a newer, updated version of that, okay? For our agenda today, as I said, this is the second run or the first day of this particular boot camp. So I will be adjusting or tweaking it based on the feedback and the comments and the questions that come in, probably dropping an FAQ in, maybe even adjusting some of the content. I've built out the structure today to talk through a high-level introduction of the various continuity services that we offer. We'll go through recovery plans. We'll look at recovery testing. We'll look at building out a recovery location and what that actually is. We'll go through and configure a standby image and a one-time restore, both into Hyper-V environments and into Azure environments where capable. We'll also talk a little bit about some upcoming roadmap items. We'll look at time allowing, some cost calculators, and discuss that and some budgeting aspects of it. While I'm not a sales guy, I can give you some very high-level ideas around pricing around some of these various features, at least as they relate, in regional U.S. dollar sites. If you've got specific pricing requests and things of that nature, I will request that you reach out to your customer success and or your account team, and they can give you an exact quote for some of these advanced or enhanced continuity services. But I can talk, like I said, high level. So continuity services. Continuity services that would be the umbrella continuity with which we have been building out several new features and functions over the last, realistically, 3 to 4 years. Our first introduction into continuity services was recovery testing. It was one of my final projects in the product management team, building out the roadmap, getting recovery testing up through the initial beta phase before I joined the Nerds team. And they've actually stayed pretty true to that roadmap with some slight adjustments here or there since then. And they've released several modules in the continuity platform. Now, it's not done by any means. Let me give you a high-level overview of some of those, and we'll talk through these guys today. We started, like I said, with the Enable hosted recovery testing, and this is a bi-weekly or monthly recovery test, and this is going to work on your Windows servers or Windows workstations with a selected size of under 2 terabytes. We've got standby image, and we can do standby image for Windows servers and or workstations, and I can restore this back to a Windows server, and maintaining a offline virtual machine in standby ready state that could be booted and failed over to in just a matter of moments. So it can exist on a Windows server as a flat VHD or VHDX. It can exist on a NAS device like an SMB3 storage device as an offline VHD or VHDX, or it can exist on a Windows Hyper-V server registered with the hypervisor, so that it could be automatically booted and have screenshots created behind the scenes, not only to be there in the event of a disaster, but also to provide proof of life, proof of bootability. And that's got a lot of benefits above and beyond the hosted recovery testing, because it doesn't have any limitations around size. So basically, you take your recovery testing in-house on your own Hyper-V system. Standby image to Azure is a fairly recent release in the last quarter to 6 months, if you want to count the engineering preview and early beta phases of it. But in GA state, it's only been around now for maybe just over a quarter. Standby image utilizes our virtual disaster recovery technology found inside of Cove to create and or update a offline virtual machine as of the last restore point in a Azure native environment. So no longer do we have to build out a nested Hyper-V in Azure and then restore into that nested Hyper-V. I give you a Azure native virtual machine where you control the size of the instance and the region for it, and it'll have the security and the networking settings that you want. That could include RDP access and a public-facing IP if you choose. A unique feature of this is that we allow you to configure and control the boot frequency. So while it might be updating with Delta changes every hour, every 4, every 6, every 24 hours, you can control the boot. So it's only booting, with each session, daily, weekly, bi-monthly, monthly. That way you can help control the costs of booting that virtual machine in the Azure environment. The question that came up almost immediately this morning was, well, is that an Enable Azure environment, or is that the MSP Azure environment, or is that the customer's Azure environment? Well, it's going to be your Azure environment, and that could be you as in the MSP, a colo that you're utilizing to service multiple customers, or it could be individual owned instances that you're managing for your customers. Maybe they're utilizing Azure AD, or they've already got some Azure systems. Ideally, the recommendation is for you not to get in between Microsoft's billing process and your customer. That way, they're licensing and controlling and paying their Azure bills. You're just managing recovery into that environment for them. And that's going to provide the highest level of security, ease of access, and configurability. You don't run into a situation where you've got multiple end customers sharing a single Azure tenant and having to worry about isolating and compartmentalizing those so that the systems don't have accessibility to others, cross-machine bleed, if you will. Another recent feature that we introduced right around the same time we did standby image to Azure is we introduced one-time restore or an on-demand restore into Azure. So where standby image is a proactive recovery, you're planning for this by keeping an offline virtual machine that could be booted within just a matter of minutes once your customer notifies you of an outage. With an one-time restore, this one is reactive. The customer calls you, says, hey, we've got a problem. You hadn't planned for this, and they don't have a standby hypervisor sitting there. They don't have replacement hardware. It's going to be days before Dell or HP can get out with replacement components, even if they're available, assuming the machine is still in warranty, those kind of scenarios. Here, you could spin up an Azure instance or take an existing Azure instance and build that virtual machine on the fly, specifying the exact point in time restore that you want to recover to, boot that system, and then flip over and run there. You could also think of this as a migration tool that could be utilized to flip customers from on-premise to running natively inside of Azure. So it does happen from time to time. With a failover, the end customer may choose to stay in an Azure environment. Ideally, you'd want that to be their environment, not one that you own that you'd have to get them moved out of later. Couple other uniquenesses here with an on-time restore. One-time restore is a great tool for ransomware. So you're hit by a ransomware, and maybe you don't need to restore the most recent point in time because it may have been compromised. You want to go back and restore a exact specific restore point from a prior day's backup. You've got that specific session restore capability here, and you have some optional functionality, so you could choose to potentially restore just the boot volume as opposed to the boot and various other data volumes. So you can get the domain controller back online faster and then selectively restore data in a data volume after you partition those volumes or moved volumes around on the network. Some roadmap items that we are currently developing, have been developing, or are in the short-term development over the next 3 to 6 months. We've been working the last several months on improving recovery testing success. So each of our monthly releases has had enhancements and fixes introduced to help increase the likelihood of successful recovery as part of our recovery testing. And that would also be the likelihood of the screenshot and the boot on standby image or one-time restore as well. So it goes cross-platform. By increasing the likelihood of the screenshot, we increase the likelihood of success in almost all restore scenarios. And that's something that's happening with each of our monthly releases. The team has been looking at, the low-hanging fruit, the fixes that can get the most devices at one time, and they're just kind of ticking those off the list as they complete them. So very, very happy with those enhancements. And I'm sure we'll continue to do those for the foreseeable future. Another enhancement is taking the one-time restore functionality that was built out for Azure and backporting that on-demand restore capability into the Hyper-V environment. That'll give us restores that are proactive through standby image, and it'll give us restores that can be done reactively directly onto your own hypervisor through the management console. So same kind of functionality there, the ability to pick a specific VDR session or point in time, and then most likely optional restore just boot volume or selected volumes versus the full machine. Another future short-term roadmap item is expanding the standby image functionality from supporting restore to Windows native machines and Windows hypervisors to also support restore to ESX hypervisors. We just finished testing on ESX 8 and we'll be rolling or porting that standby image functionality to ESX here in the near future. Obviously, roadmap items, hashtag forward-looking statements, okay? Harold had a question here that came through. Can we get a screenshot test certification for standby in Azure? Absolutely. So if we do the recovery testing, that's going to be a case where we're booting it in enable managed AWS instances, AWS bare metal instances within regions. But if you utilize standby image to Windows or to Azure, then yes, when it's scheduled to boot, you can give it an email address and it will send out that validation to you. And that's normally going to help you fulfill those recovery testing. Did you test your backup requirements that you're getting from your various cyber insurance policy, or cyber insurance agencies. Okay. So where we want to start with this is going to be with recovery plans. Recovery plans are a very broad topic. At least they will ultimately be. We started with them very, very simple. We built a recovery plan to do recovery testing. And it did a once a month recovery test. It worked in just the US and German regions, and then the UK, and then a handful of other regions. And then it expanded from 500 gigs to a terabyte to 2 terabytes in size. So these plans have been adjusted. Ideally, a recovery plan will support customization, so you can define your own plan. What am I booting? What am I selecting? What am I restoring? How frequently do I restore? How frequently do I boot? When do I boot? When do I shut down an instance? When do I bring an instance back up? When do I send notifications? Those kind of things. But as we expand out the various offerings, we continue to expand out the number of recovery plans that are available. As it stands right now, when you add a device to a plan, you're going to see 3 recovery plans. That's recovery testing, which will then further get expanded into is it once every 2 weeks or once a month for frequency, or a standby image plan. There are 2 targets, standby image into Hyper-V and standby image into Azure. Those require that you have a system running on your Hyper-V environment or a piece of software running in your Azure environment on a virtual machine in order to receive this plan and to orchestrate the recoveries. So we'll go into more detail on those as we go through here. I want to bring it up in the live UI as well for you so that you guys can see that a little bit deeper. Let me flip over to that environment. Bear with me a second. There's the one we're looking for. So continuity and the continuity offerings are listed here under the continuity section on the left-hand side of your navigation bar. So we see recovery locations, we see recovery testing, standby image, and one-time restore, but there is no plan. So how do you know if something has a recovery plan tied to it or not? Well, there's a couple ways. One, you can go to columns, and we'll go in here, and we'll just do a quick search for recovery. And we can see there is a column I-80, called Recovery Plan. We'll go ahead and turn that on and hit Save. And that's added a new column to my dashboard called Recovery Plan. You can see that of my 2019 devices here, I've got 2 devices with standby image on them, and I've got 2 devices in a recovery testing plan. If I were to click on one of these systems, I can see that I've got the ability to pause restores up here. So that means it's in some type of standby image configured plan. If I go to settings, you can see general information, backup information, product, and profile. And as I go down a little bit further, you can see that it's part of a standby image to Hyper-V plan. This is the plan that's turned on. This is the recovery location. This is the actual Hyper-V system where the virtual machines are being staged and kept in an offline state ready to boot. If I wanted to have an email address in here to send that daily or periodic email report, I can drop that in right here. I can even modify the configuration a little bit as to whether I'm going to register it with Hyper-V or make it just exist as a local VHDX, choose where I'm going to store it, on local SMB storage or on local volume. I can adjust the fact that it's booting and taking screenshots, or if it's using a local speed vault. Even adjust the number of CPU cores and RAM that it uses to create the virtual machine. What's the virtual switch assigned to it? If I want to adjust the IP addresses for when I boot it, that information can be dropped in here as well. So that way it's got a IP to match the subnet or the VLAN or the NAT that you're sitting behind. And let's go down a little bit further. You'll notice there's a second standby image here. So this machine actually exists now in 2 recovery plans. It's in Hyper-V and it's in Azure. This is a relatively new enhancement in the last 30 to 45 days that allows us to allow multiple standby image recovery plans. You could have one that you're using for failover in the event of corruption or ransomware, and another one that's for failover in the event of total site loss. And you'll notice I'm getting emails here on this one. So let me step out of here a little bit and take you guys in a little bit deeper. So recovery testing was that first recovery plan that we introduced, and there's a lot of value to be had from recovery testing. So let me talk a little bit about the requirements and give you a little bit more overview of the service itself. It is a chargeable service. That doesn't mean it's the only way to get recovery testing, but it is a methodology to do automated recovery testing so that you don't have to get your techs involved in that day-to-day manual testing of all of those workstations and laptops and servers inside of the various organizations that you manage. What this is going to do, it's going to synthesize a virtual machine, restore that to a enable managed AWS bare metal recovery instance within country, within region, geographically of where your backup data resides. It's going to boot it to test recoverability, screenshot it, and then shut it down and purge that virtual machine. It's going to do that inside of an isolated network, so that way it's not able to talk to anything outside in the real world, no network time servers, no domain controllers, no other bleed to other VMs on the same network. It only exists during the restore time and the boot time, and then it is purged. Log files are kept around, but not the machine, at least not in a persistent state. We do this for that proof of life, that proof of recoverability, but it's not a true failover type of solution. We're going to store the screenshots in the management console. We're going to send those out via email. That way you've got that proof of life as well. And it restores Windows file system data, so server and or workstation, system state, and SQL database environments back into the infrastructure. It's something that could significantly reduce the overall time required by your technicians and the resources and hardware involved by your techs to perform manual disaster recovery testing. That's going to help fulfill some of the testing requirements that are introduced in many of those cybersecurity insurance policies. Now, obviously check with your carrier and see what their frequency requirements are and what machines and things of that nature. And it's not going to replace having a tech come in and do a periodic manual test of those important servers, those line of business applications. The owners, CEOs, executives, anybody can hire, fire, or adjust a contract at a customer. But even if you had all of your technicians coming through and doing recovery tests manually, you might have too many devices to be able to do them all in a reasonable amount of time with enough hardware and resources and bandwidth to get that done in a full cycle before you have to start again. So think about this to help augment that one, and then pepper in spot checks for key systems where you do a manual disaster recovery or a hybrid recovery where you've utilized the standby image functionality and you've just come in and booted it periodically and ran some of your own tests, your own scripts, a DBCC check, or sent an email, those kind of things. Once again, if there are any questions, please let me know. Drop them into the into the question section of GoToWebinar, and I'll grab those. James, it looks like you had a question here. How do we add a second recovery? I will show that off to you guys here in just a moment. So you'll see that as part of my demonstration. Other requirements here, 64-bit Windows server shouldn't be a problem. Can't do bare metal recovery or virtual recovery or testing on a 32-bit system. Can't support the older Windows XP or Server 2003. But anything after that should be able to, as long as it's 64-bit, should be able to be booted, tested, and screenshotted. We do have a limitation, as I said, of selected size of 2 terabytes or less. So if you've got machines that are larger than 2 terabytes, your only real option is going to be to do standby image or utilize our recovery console application to perform your own continuous restores and screenshots that way. We also restrict recovery testing. We don't allow it for our software-only customers. That would be those that are doing their own self-hosted storage nodes. We don't support that. We would be generating a lot of outbound traffic from those storage nodes, which would be, undue load on customer-owned hardware. So here's a quick screenshot from a recovery testing perspective, just so we've got some static views here. This is using our SE demo environment. You can see I've got 14 successful completed recovery tests. Several of those in the last 7 to 14, or 14 to 28 days. And they took various amounts of time, a majority under 4 hours, some took between 4 to 12. Larger systems, different workload, and these are broken out across different geographies. There you can see inside of this environment we've got multiple historic recoveries. We showed the last 14 in the color bar. We have the ability to click and view a screenshot for a given device, and information around whether it was a successful boot, and then you can drill into this to get more detail on those. Let me pull into my demo environment here. And as I said, I've got some cases where I've done videos of this to ensure that it's consistent across the board that I'll just talk to, and then I'll bring in some live UI here in a minute. Same exact dashboard though. I'm working with my HEH computing environment, a handful of Windows 2019, Windows 2012 systems in here. We go to the recovery testing section on the left-hand nav. What you can see here is a handful of systems. I've got some successes, I've got some failures. All 8 of these devices, the recovery test has been more than 28 days. So we can see that here. Those should be scheduled for an update here very soon. I've got 5 completed, 2 had completed with errors, 1 is currently in a retrying state. And all of these were able to be restored in less than or sub 4-hour recovery time. You can utilize that as kind of a base rule of thumb of how long it takes to restore that machine in a customer or production environment. Obviously, bandwidth and hardware could impact that somewhat, though. So as we look at the 28-day color, I'm sorry, the 14 session color bar here, we can see successes and failures. And if there are failures, there will be errors related in the console here. We can sort by error counts and drop all those down to the bottom. And let's go through some of these. A 3-hour and 31-minute duration. Let's look at the screenshot for this guy. So recovery testing verification here. This is my login screen for this particular workstation. That's a Windows 10 machine. So that is there. That would be emailed out to you as well. It's part of a bi-weekly plan. We can take a look here at some of these server systems. This is a 2012 R2. So we can see this was a June 22nd session. That was restored. You can see service information down here, so we can see where we started up the machine, various services started inside of that. Since it is isolated, there's no external network access. Any type of NTP server, or domain control, or a SQL connection is going to stop or fail, but any internal services that can start will start, and you'll see that information here. That information is also logged locally, and could potentially be parsed for reporting or additional verification, I guess. A couple other examples here as we go down the list here. So completed successes for various systems, different services. We'll take a look at this one. Yep, successful. Let's look at some of the failed or completed with error devices. So we can click on the error message itself, and we can see insufficient system resources exist to complete the requested service. This is most likely not enough RAM or not enough CPU cores on the machine in order to boot it to get the actual screenshot to work. Here we have a failed to check file system object existence and a non-bootable file system. It's possible that I did not select enough data in the backup to actually make a bootable VM on that system. Now, with recovery testing environments, there's only so much troubleshooting you can do because it's being restored in a enable managed environment. So you would want to open a support ticket, and our application engineers are going to have to be involved in order to get more detail beyond what you're seeing in the console here. If we want to add a couple of new devices in for recovery testing, we can do that. So we'll add it to a recovery testing plan. We'll pick the frequency. We can pick a couple of my devices here, and this is going to give me a list of all the visible devices in my console. I can see which ones are compatible or incompatible or already in a recovery plan. Now, why is something incompatible? Because maybe it doesn't have system state. hasn't had a file and folder backup. It's not configured for virtual disaster recovery, meaning it's not enabled in the default product. It's a Linux system. It's a 32-bit system. It's a documents-only device. That kind of information is going to show up under the incompatible mouse over as to why, so you could rectify that if possible. You can sort, search, filter here a little bit. So if you want to sort on profile or compatibility or customer name or computer name, device name, you could do that. You can't actually support filter on like operating system right now, but you can also search in some various keywords. I'm going to search on 2019 here or 201 to see all my 2012 and 2019 machines, but it's filtering on device name and computer name, not truly on the operating system itself. I just happen to name my machines conveniently that way. So we'll pick a couple. These are compatible devices. There's a 2012 R201, 04, and a couple others. So here they are. These are all auto-deployed. The passphrases are managed by the system, so it detects those automatically. We can bulk add an email address into this to receive the notifications of successful boot. I'm going to use some plus notation here so that I can have it go from a unique address, and I'll apply that to all devices. Now, if you've got some that you also want to send to your end customers, come down here and hit the edit, and you could actually separate the email addresses with a semicolon, and that will allow you to go to my centralized MSP dashboard as well as possibly to the end customer or to some other alternate location when it sends out. Now you could skip that step. If you only want to see this in the dashboard. Those are successfully assigned and configured. They've been added now into a monthly recovery testing plan, and you'll see those show up in the dashboard under recovery testing now as scheduled. They're not necessarily going to kick off immediately. They're going to go into a queue. So it could be a day, 2 days, 4 days, 7 days, up to even 14 days if it's biweekly before that gets into the queue, depending on how much load there is right now. But those are scheduled to start doing that recovery test. Several columns here that you can turn on in the column section. So we can see various configuration data around recovery testing. If you want to pull this data out, you could do that as well with the export option up here and get a report through Excel or CSV. There are other ways to get this data as well through the API, and then even partners like Backup Radar, for example, they can pull this data out in their reporting feeds as well. One of the requests I had this morning was, is there a way to pull this from Incentral so I can monitor recovery tests for inside of Incentral? I do have some sample PowerShell that I've put together that can allow us to pull that information on a device-by-device basis when it was last successful. So feel free to schedule some time with me and reach out if you'd like to go into more depth on that one. Here's the sample export. So we can see here all the various devices, their current recovery testing plan, their last 14 days here, completed with error, and so on, current status, timestamp, amount of data transferred, number of files, those kind of things. Okay, let's see, what do we have next? We'll do a quick refresh. Yeah, nothing started yet on those, but they are scheduled. I do believe they have successfully completed since then, so I'll bring up the live dashboard here in a few minutes. We can see if they have concluded. Let's see. Yeah, here we go. So I did throw in a quick screenshot on this one. So here we can see 2019 recovery test monthly, some of the other 2012, 2019 systems. So yeah, those did ultimately get completed environments. So now green inside of the console or green inside of the dashboard. This is a screenshot for consistency. If we go back to the live dashboard here, back to recovery testing, we'll let this refresh, and we can see, yeah, all of those last completed sessions, that test completed yesterday at 10:46 a.m. So it took 8 minutes, 5 minutes, 8 minutes, 14 minutes, 14 minutes, and that's a full restore of the virtual machine in order to build that system. They're not huge systems, but these are pretty good restore speeds. Okay, let's do a screenshot of one of these. We'll grab this one right here. 8 minutes. 7:01, Tuesday, August 29th was the boot time, um, utilizing a August 28th 4 a.m. session that it used for the restore. So always restoring the most recent possible session when it does its test. Oh, and then here, yeah, with just your event information and service starting information. So recovery locations do exist in the dashboard, whereas recovery plans aren't as visible. But recovery locations exist right here inside of the dashboard. And if you've used our recovery console application historically, you could think of each recovery location as being a dedicated recovery console sitting someplace. We've changed the terminology around a little bit, though, to differentiate. So recovery location is the named location, and there's a piece of software running on each of these locations called a recovery service. And I'll show you how to add that recovery location and install that recovery service onto these environments here, okay? So the recovery locations, it's going to be one or more Windows systems out there that you're using to host a running recovery service that's going to process restores. It could be used to synthesize, update, mount, host, test, or manage an offline VM image or virtual machine. And I say VM image and virtual machine a little bit differently there because it could be a VHD, VHDX, it could be a registered VM with Hyper-V, or it could be a virtual machine sitting inside of Azure. So, which really isn't necessarily a VHD or VHDX, truly, I guess. Each of these recovery locations, by default, is configured to handle up to 5 parallel restores. And you figure a restore might take 15 minutes to an hour, or 15 minutes to an hour to 4 hours, maybe on an initial run, things like that. So you could have multiple VMs restored throughout the course of a day, even if you're only running 5 parallel. But you can adjust that number of running parallel restores based on the number of virtual CPU cores on your hypervisor or in your Azure recovery location instance. So some default configurations, this is straight from the documentation. If you're looking to do a large number of simultaneous restores or restore multiple machines within a 24-hour period or within a week, then you might turn around and take a Windows server with a Hyper-V role or a Hyper-V Server 2019 Server Core role. It's the free hypervisor available in 2019. And you might use those to boot nested VMs that you're recovering. In a situation like that, at a minimum, probably 22 CPU cores, and those could be virtual cores, or more to facilitate your boot testing and the occasional spin up or the occasional failover and running these standby virtual machines. That's the whole point of providing continuity services. It's not just testing, it might be actual failover and temporarily running on these machines. And a minimum of 32 gigs of RAM. Obviously more if you're expecting to have 2, 3, 4 machines failing over at the same time. Something to think about when you're sizing all of this out. And I've done a blog article and some other documents around estimating and sizing. But think about the production CPU requirements and RAM requirements of the machines you're protecting, and then come up with a number, whether it be 60% or 80%, and try to consolidate your systems down to that range. So maybe your initial server was a 16 core, 32 gig RAM machine. Running SQL databases. But from a recovery perspective, you're going to run this now with 12 cores and 24 gigs of RAM, knowing that it's going to run at a slightly degraded state so that you can have other systems running on that hypervisor as well, not eating up all of the disk I/O and the RAM and the CPU. So it gives you the ability to over-provision your hypervisor a little bit, assuming you would never fail over all 5 or 10 or 15 machines at the same time, some percentage of that. Also take into account that if you do start to utilize a recovery environment like this, you might end up pausing some of your restores while you're running it in a failover state to provide availability for other failed systems. So adjusting your schedules, pausing your restores while you're using it in a failover state. This is no different than you would do with a competitive appliance-based BCDR box. We just give you the ability to utilize your own hypervisor or Hyper-V core infrastructure with your own hardware. You could repurpose off-lease, out-of-warranty hardware inside of your organization as you repair it and replace it. You could purchase refurbed hardware from various liquidators online and actually get, tier 2 or tier 3 hardware that's actually warranted for 3 to 5 years at pennies on the dollar as to what it originally sold for. That make great recovery boxes or BCDR BCDR appliances. Other things you can do if you have a prior BCDR vendor that you're moving away from is you can think about rooting or repurposing those appliances. So that's a matter of looking at the hardware, determining whether it's still scalable and capable of running and managing virtual machines, logging into those systems, wiping those systems. Typically requires going into BIOS, maybe securing a password from the vendor's website, their support site, or Reddit even. Rooting that system, maybe replacing the boot drive or upgrading some of the disks inside of it to make them faster or higher capacity, and then utilizing or reutilizing those appliance resources now to act as a recovery location for Cove. If they're older machines, if they were just really used mainly for NAS purposes and local stores, they're also capable of being reutilized. Maybe not for recovery locations, but for local speed vaults. You might consider throwing on a free NAS OS on there and then just turning them into SMB share style NAS devices, connected via UNC Path or iSCSI. It doesn't have to be a hypervisor, though. You only really need that if you want to boot, these nested VMs and take screenshots and fail over to them. If you just want to have a offline virtual machine, something you can mount or connect to or create and then move to a hypervisor later if you need to, you could set up a Windows server with direct attached storage or SMB3 storage and restore just flat offline VHD, VHDX images. Obviously, no failover, no boot capability in this state, but in doing so, you would have a lot less CPU requirements, a lot less RAM requirements, just processing parallel restores now, not actually booting or testing or failing over. If you want to go to Azure, deploying a recovery location in Azure, at a bare minimum 12 core to act as the orchestrator with a minimum of 16 gigs of RAM is what we recommend if you're going to do multiple parallel restores. You could use less than this if you're only going to do 1 or 2 parallel restores. If you want to do more than the 5, then you want to bump that number of cores up, or even think about a second recovery location, maybe in a different region, to help facilitate those restores. Okay, some minimum requirements around Azure if you're going to do this, and I only point this out because on the Hyper-V and the Windows Server side, you're going to be a local administrator or a domain admin. But from an Azure perspective, you're going to need access to the Azure subscription. You're going to need access to the resource group where you're going to host the recovery location virtual machine that we're going to create. I'll show you how to do that in the UI here in a minute. And you're going to need to be able to assign some permissions on those virtual machines within the resource group so that the recovery location has the rights to assign disks to other virtual machines, move things around, create virtual machines. Effectively, the recovery location will act as a proxy communicating to Azure APIs in order to build virtual machines and interact with the infrastructure. Simon had a question that came through here. Do you have a recommended NAS hardware for on-prem DR solutions attached to a local server? Simon, I can't really say a recommendation, but I can tell you what the majority of our partners use. Inside of the MSP community, I see Synology as by and far the number one vendor that's utilized for NAS devices, typically for using as a local speed vault. And that would still be connecting to it via SMB or CIFS protocol. While you can carve those up and utilize them as iSCSI, I found that the iSCSI connections are going to be less secure because it's just a file system at that point. By going SMB, you can have it as a workgroup level device, not part of the domain, and it isolates the security a little bit better for the data. Secondarily, used to be QNAP. They've had some issues as of late, a couple different security scares and some other enhancements they had to do in order to secure up their boxes. But they're still probably a strong second. Buffalo NAS comes up quite a bit as well. I've heard about some really, really good advanced replacement policies and things like that when partners standardize on those devices and they're buying enough of those. I see vendors that sell these NAS devices. I see vendors that lease these devices. I see vendors that own them, and they provide them as part of their monthly subscription and service. And if the customer were to drop Cove Data Protection, then the NAS comes back and gets reutilized or repurposed. So that's really up to you and the buying models and selling models that you guys use. Good questions. There's a couple others here that I'll grab too when we get to the next section. So for recovery locations, here's a system with fully loaded recovery location. It's a way to essentially see all of the places you're doing restores behind the scenes. And this is one of the advantages of this over the prior recovery console installation, where you had these islands of recovery happening, but you didn't have any centralized view as to where they were all being configured or managed, how much space was being consumed, or how much RAM was available, or devices were assigned to a particular recovery console. Here you can see this. You'll notice I've got a mixture of Azure as well as self-hosted Hyper-V systems. Some of them are booting, going to local disks. Some are going to network shares, like this one right here. Just a good representative sample here, so I wanted to have that as a screenshot before I go into the actual demo portion. So another recorded video here. I may skip along a little bit in this one. I think I need to shore my timing up on it a little bit, maybe get rid of some of the dead space as well. But starting inside of the same Cove dashboard here with my 2019 devices, we're going to go to recovery locations on the far left. You're going to see I've got a single recovery location right now. This is a Hyper-V recovery location. It's running on my Ivy server. I do have a Gotham/Batman fetish with my server names, so I had comments on that earlier. Effectively, we're doing restores to the H volume, creating folders in the standby image SPI directory. I've used 2.7 of the 8 terabytes available. I've got 127 gigs or 128 gigs on this machine running 2012 R2 Hyper-V. I'm going to come in and edit the recovery location. I could change the number of parallel restores this machine has configured. It's actually 40 virtual cores with about 50 terabytes of disk behind the scenes. So I could do a lot with this one, although it doubles for a couple other functions as well, some production hosting. If I go to history, you can see prior restore sessions. This is that continuous or standby image. This restore is constantly happening after each new backup session. It lays down Delta restores, and in some of these cases, it just takes a few, 3, 7, 10, 6, 8 minutes to do the Delta updates. So that type of restore log there, I'm going to show you an example of that in the old recovery console here in a minute. If I wanted to add a new one, I'd hit the Add Recovery Location button. I could pick a customer and build a recovery location that's going to be self-contained within a particular end customer or a site that would only be good for their devices, or I could build it at the top level and make it available for multiple devices across multiple customers. Notice there's a toggle here, self-hosted or Azure, and a download button. It's going to create a unique installation package. So download the file exactly as it comes. Do not rename the file. The alphanumeric string in the file name is very specific to its installation. It's only good for a single install. Even if you uninstalled it and went to reinstall it later, you would need to get a new installation because it's keyed for silent installation. So there's no other configuration you really have to do on the Windows server where you're doing the restores. Everything else is going to be managed from the console itself. Okay. So notice that it hadn't, just because I downloaded it doesn't mean it hasn't shown up yet. I'd have to go to another Windows server. I'd have to run that installer, and then it would pop up in here with a couple different configuration requests, asking me for the storage location and to come in and configure the number of parallel restores and some other various settings. Now, I mentioned the recovery console. This is the legacy recovery console application. If you look at this, it's configured for 5 restores. Some of those are continuous. So those have happened, within the last few hours. Some within, within the last 49 days. And we can see the restore processes where it's doing that same continuous restore on the right-hand side. So principles are very, very similar between the recovery console and the recovery service. You can see here running on the same machine. I have my recovery console service and I have my recovery service controller, the newer technology. This is a 23.7 build. So it was my July build. If we go into File Explorer, we can actually look around the installation path and see some of the things that it creates when it does the virtual machines as well. Here on the hypervisor, you can see I've got several devices labeled RC, several other devices labeled standby image. These are all offline virtual machines right now. In the event of a failure, I would just boot one of these guys up and connect my customer to it, and he's got his standby as of the last backup session. Let's see, File Explorer. We're going to go to H drive. I was H/SBI for standby image is where I have everything configured. And you can see there's a standby image directory there. There's 2 directories based on device names. If I come into here, you can see the files that we create for the recovered environment. Here's my virtual machines, the virtual disks, the AVHDX and VHDX files that were created for the system, as well as virtual machine config, snapshot, XML directories, and things like that for the VM config files. System event logs. This info file here is the event logs that showed up for all the services starting on the last boot attempt. So that could be parsed or edited or utilized as proof of performance as well. Here is the screenshot in the screenshots directory. So we can see here's my most recent screenshot. Once again, it's proof of performance if you wanted to grab it or work with it from the local system as opposed to looking at the logs or what's stored up in AWS. Documentation. So there is a link to documentation for Cove in my handout document. Let me show off a little bit of the documentation here. I don't want you to think about this training being the only way that you learn how to do or deploy some of these services, but I want to deploy an Azure recovery service, build an Azure recovery location for you guys here today, and then we'll do some live restores to it on demand and continuous. So let's get to here. So we're going to go to our documentation site. And once you're inside of the documentation site, I've got a full section devoted to recovery. We're going to go to continuity in management console. Once I'm inside of there, you're going to see recovery testing, which we've already talked about. Standby image to self-hosted, Azure recovery, disabling recovery services, recovery locations. So we're talking about recovery locations right now. We'll expand that out. And you can see we've got installing the enable recovery service on a Hyper-V server 2019. We've got adding recovery locations. We've got up here Azure recovery. And we have an option to install the recovery service on an Azure recovery location. That's what we want to go through right now. And it's broken into 6 steps. Downloading the recovery service, creating a recovery location VM, assigning permissions, installing the service, adding antivirus exclusions, which is optional but recommended in a lot of cases, and then configuring the recovery location in the console. So those steps I'm going to outline in my PowerPoint here as well. But this is a great site because it walks you through each of these with screenshots, with recommendations, so you can just follow along right through here. I utilized this when I built the recording for this session. I did run into a gotcha or two here or there where Azure responds a little slow. I clicked something, followed the exact results, and it didn't do anything, and I waited, and then I looked around and I found another box that I missed, or I had to go back and go forward and refresh. And I haven't edited those out of the content yet because I want to find out if these are stopping points for other folks. Ultimately, yes, we'll get a fine-tuned version of this one, which is the exact set of steps, and we'll highlight where the gotchas are so that you don't make the same mistakes that I did. Okay. Um, so let's get back to downloading the Azure Recovery Service Installer. Um, this to me seems like the step is a little bit out of order, but I'm going to follow it exactly as it is in the documentation. I do have some recommendations on how we might be able to do this through a very simple PowerShell script, both the download and the install without actually even having to remoting into the machine. So automating the deploy even further, but something I'll be working on in the coming weeks. So let's start with the management console here. We want to go into recovery locations and want to build a new recovery location. So we'll hit the plus add recovery location box in the upper left-hand corner. I want to do this for an Azure environment, so I'll change it from self-hosted to Azure. It's going to give me a unique package keyed to a particular partner and keyed to a particular um, uh, location. So we'll see that download here in just a second. And I'm going to download this, and I'm just going to leave it on this local system. Later, when I RDP into the VM I've created inside of Azure, I'll copy this file over and actually launch it or execute it. But for right now, I'm just going to create this and set it aside. And you notice here that it tells me the recovery location will appear here after installation. It doesn't show up yet here. It has to be installed on that Azure virtual machine. And I haven't created the Azure virtual machine yet, so uh, we'll do that. So now we want to create a Azure virtual machine. Um, Not an Azure expert here by any means. I can get around. I can build a virtual machine. I can do some security things. But Google is your friend. There's no replacement for going out and doing an Azure certification or some Azure training to get a feel for it, especially when it comes to security, isolation, VPNs inside of Azure. But from a lab perspective, some basic testing here so that you've got a little bit of familiarity. The first time a customer calls, you need to go, hey, I need to do this. Makes a lot of sense. So we are going to start um, um, in the Azure portal. Obviously, I could go through the training that's there, but I'll say maybe later on that one. We're going to start by creating a new virtual machine. We make some recommendations in our docs as to the size of the virtual machine to create and the configuration for it. I deviated a little bit from that just to prove that you could. I used faster disks. I used a machine with more IOP capability. I got a pretty decent restore speed too for the machines I've created, so I think that was beneficial. But obviously your mileage may vary, and since this is Azure, you are paying for this. So keep that in mind as you size these things. And remember to shut them off when you're not playing with your lab, or sign up for an Azure trial even so that you can get that free monthly $100 or $200 credit if it's offered to you. If you are a Microsoft Gold partner or Microsoft partner, you might actually have some free monthly Azure credits you can utilize also. So we're going to create a new Azure subscription here. We're going to create a new resource group. I get messed up on spaces and underscores, and when I can have a space or a hyphen and an underscore, and can I use numbers or other special characters. So it takes me a little while to figure out exactly how I'm going to name some of these guys. Think about this structure as you're going through this, though, so you're keeping consistency here. You don't want to build so generic a name that you don't know whose system it is or which customer it belongs to, okay? And in this case, the hyphens or underscores are not allowed for the name, but they were for the resource group. Kind of odd. I'm using the U.S. East region. I'm here based in Raleigh, North Carolina, so that was going to keep it fairly close to me. I'm using data coming from the U.S. as well. I'm not using any redundant infrastructure here from an availability perspective. This is just a failover environment. That is my redundancy. I don't need to pay more for it to be mirrored in multiple data centers. And I'm going to build this off of a Windows Server 2019 image, I think. Yeah, 2019 data center is what I'm going to go with. Now, it defaulted to the standard D2S V3, 2 virtual CPU and 8 gigs of memory at $137 a month. I could have used that one, but I'm not going to get 5 parallel restores out of 2 virtual CPUs. That's good for a 1 restore at a time. I went in and started looking around a little bit, and I went with this quad-core DS3 V2, I think it was, or DS Yeah, I think it was a DS3 V2. So 4 virtual CPUs, 14 gigs of RAM, um, around 1,200, I'm sorry, 12,000 max IOPS. So I was looking for high IOPS. Now this has got a $367 a month cost. So I was running this continuously. I would need a lot of parallel restores happening in order to justify, those kind of resources. But for this lab purpose, I thought it made sense to, go a little bit above and beyond. I also set up the storage to utilize SSD as opposed to standard spinning disk. I think that can have an impact potentially on restore speeds. Create your usernames, your passwords, store those, unique passwords, use a password manager, things like that. And I did have a couple gotchas as I was going through and building and configuring out this system also. I started looking at how am I going to connect to this machine? Is it going to be through RDP? Is it going to be through Bastion? That's an internal remote client. Some of our partners say, oh, well, they use RDP just briefly and not long enough to get on the machine and install a copy of Take Control, which makes sense also. You need some method to interact with the virtual machine. There is a possibility actually to run PowerShell scripts in the virtual machine through the Azure interface, which could allow you to install software, configure functionality, install a take control or a team view or a screen connector, whoever your RMM tool of preference is. So there's several ways around this one. Other settings in here that I found too, there's a validation phase and it'll test all of your settings to see if they are valid. I actually had that fail. I went back and looked at it a couple times. You'll see that in my screens here as I'm going through it. But I didn't really change anything. I just went back and re-clicked the same buttons, and I finally got it to validate itself. So there is a bit of latency, I think, in the settings. Maybe I'm just clicking through them too quickly, and it's not giving things a chance to fully propagate behind the scenes. We'll go into the disk configuration here now. While you could use spinning disk, I went with just premium SSDs. Why not? I did look at things like key management and some of the other settings here, just expanding, exploring above. We don't use any of these in the default recommendations inside of the docs. Obviously, if you want to utilize these things, set up your security policies based on any internal best practices you guys have created with using Azure. Don't stray away too far from your standardized policies. Obviously, if you're restoring data and it's production data, customer data, you want to be very careful about putting that on an open port to the world, having RDP open, things of that nature. So setting up secure networks and isolation makes a lot of sense, especially coming in from certain IP addresses and things of that sort. Here, I'm working with non-production data with just lab machines, so I'm not as concerned about it from a demo perspective. Let's see, I want to move along a little bit here. I want to get to the point that I actually got to my conflict. So there is a point where you hit the create button, and it comes up and does a validation. So validation failed for the following tab, basic. There was some required information that was missing, but if you look, there's no information missing here in my basic tab through, and I started clicking on each of the fields, choosing the drop downs again, trying to figure out what did I miss, if anything, and I couldn't find anything that was actually missing. So I cycled through again, went through the entire process. Basic is still showing me that it's failed, and went through these a couple times. Once again, not actually changing anything, just clicking and confirming existing settings, and I did that for a couple minutes, probably 2 minutes, trying to figure out what did I miss, things like that, before I was able to come back and hit the review and create button, and it accepted it. So if all this fails, timing, step back a little bit, validate your choices, give it a moment for Azure to get caught up, and then proceed. Not a Cove problem, I think more just a timing with Azure environment. I am playing with a fairly low account, pay-as-you-go. Maybe I'm not getting full priority access to the APIs of the infrastructure. Now, once validation passes, you can hit the create button, and it'll actually go to build that virtual machine. And that's going to take a few minutes also before you'll be able to actually get in there and launch it. I won't make you guys sit through that entire process. I'm going to speed forward just a little bit here. Put that casserole in the oven and pull out a baked one. So deployment now being in process. This was deployed 8:30 at 3:41 a.m. So this is not something I did last week or last month. This was just recently done. Once again, just recorded so that it's consistent each time I show it. I'm not missing steps or forgetting a step. So we can see it building this guy out over the course of the next few minutes or so until we get to a completed system. I can pin it to the dashboard, go to resources, really where we're going to go now in order to start to interact with this one. Set up automatic shutdown. This is a great thing you can do. I've got mine set to automatically shut down at 3 p.m. today. So as soon as my boot camps are over, it's going to shut down this instance and help me not be charged for the compute. I'd still be charged for the storage, but not be charged for the compute if I choose to leave it there. Okay, so what have I done now? If we look at our deploy here, I have downloaded the recovery service. I've created the recovery location VM. I now need to assign permissions to that VM so that it has the ability to take ownership and build new volumes and connect those volumes and interact with the VMware API. I'm sorry, the Azure API. I need to install the recovery service on that machine. I'm going to optionally add antivirus exclusions, and then we'll configure it so that it can be targeted from the backup.management console as a recovery location for Azure On Demand and or Azure Continuous Restores. So back to Azure role assignment. So Azure role assignment is going to start in the Azure console as well. So we'll go to virtual machines. We'll select the recovery service that we built. We'll come over here and go down to identity. And I got held up a little bit here too. I was expecting things to refresh faster than they did or to pop up. What you're going to do is you're going to turn on the status here so that we can grant some permissions to this VM so that it can, like I said, take ownership of virtual disks and move things around. I expected when I turn this on for it to actually do something, but no, I have to turn it on and then hit the save button. And then once I do that, I get to magically wait another 10 or 15 seconds after I click the yes button before I will get some new pop-ups. So we'll see this guy come up here in just a second. There we go. What I want to do is be able to assign Azure role assignments to this virtual machine. So we'll come into here. You can see your subscription. I need to hit the plus in the upper left-hand corner here to provide these roles to the underlying VM. This also had a little bit of a delay that I noticed inside of Azure. Once again, not a Cove problem, but I want to point it out because it stumped me. And my documentation doesn't say, oh, you might have to wait a few moments here for this to show up or refresh. So what we want to do is we want to go in and select a resource group, select our current subscription, pick the Nerd Recovery resource group that I created, and I want to assign a owner role to this particular environment, and that owner then means they can now build virtual disks, create virtual machines, and move resources amongst them. So it says it's added here in the upper right corner. That says it's successful. I expected that to mean it would show up here in this list, but it tells me there's no assignments. Hitting refresh to no avail, waiting to no avail, going back and coming forward to no avail. It took me just waiting a few minutes, and I clicked around the entire time. I just, I watched pot never boils. Me being impatient. Did I do something wrong? Did I miss something? Was there a hidden save or a refresh button that I missed? I even came in and tried to reconfigure it a second time. But when I did that, it told me that the role was already assigned, but still not showing up here. Refresh button didn't help. I actually had to refresh the browser. I think I navigated back and then I refreshed the browser before I got it back in a place that was visible. Let me see. We'll move forward a little bit. Yep. So I came through, tried to add it a second time, failed because it already exists, but not visible. Microsoft errors. Needless to say, I did finally get a refresh to happen so that it would show up here. And we see the owner, we see owner role for the node recovery resource name and resource group, okay? This is what you need to have in order for it to be able to assign disks and move things around. So let's see. The next step was RDP. I want to actually connect to this virtual machine that I've created, and I want to install that recovery service application. Um, so there's the correct way to do this one, but even connecting in through RDP, it's something I do on a daily basis on my home systems. But RDP into Azure, a little more challenging. RDP into Azure when I'm also part of the enable corporate domain, even more challenging. Different security policies and things in place. So let me show off a option or a discussion point that I want to talk about as well. So the thing I wanted to point out on the RDP side of the house here, let me get back into my Azure console if possible. Going into Azure. Let's go to recovery service, run command. I really liked this option. Run command, let's see, run PowerShell script. So I can drop a PowerShell script in right here. That could be a command to download the recovery location installer. It could be to create the directories needed for standby image. It could be to do various things without me having to RDP into the actual device. So I kind of liked that concept. I don't know if anybody's actually used that here in the audience. If you have, you want to comment on it, please let me know. But just looking at that and comparing that to like this one here, enable remote PowerShell. So if I click that one, we can see the actual script. So it gives us a script right here to do what we want. And I can click run on that one. It's going to go off and do that. So um, I'm all for the concepts of use this raw PowerShell component or this download and install routines in order to do things inside so that we don't have to actually interact with the GUI inside of Azure or in the VM from an RDP perspective. Um, okay, I'm getting some feedback on that. I appreciate that, guys. If I missed anybody's question on the break, also, please just respond back to the question again and bump it back up to the top. But I think I got anything that was outstanding and open. So anyway, so one thought here, this could also be used in order to add in exclusions into the Windows Defender AV that we recommend that you do also, just through a small PowerShell script here. I've already got a PowerShell script to add exclusions to Windows Defender for the backup manager. It would just need to be expanded with the list of paths for the um, uh, for the recovery service. So I'll show you that as well. But let's go through the documented process just so that we are consistent here. So RDP and install the recovery service. So we're going to come into the recovery service that we've deployed. We're going to utilize, it's already running, so we're going to connect to it. We'll utilize RDP. Bastion is another option out there, actually a more secure option, but it's also a chargeable option from Microsoft. So I decided to go away from that one, just thinking about cost and expense. But do what's right for your security policies inside of your organizations or inside of your customers' environments. And that might mean that you don't utilize RDP. So I've hit this, it gives me it confirms the port's open. It gives me the option to download my RDP file. I've got my username right here I can copy and log in with. I ran into a couple challenges here, though, like I said, because I'm on a corporate domain. It was trying to log in with using my @enable email address and things of that nature. I had to preface my username with the IP address of the machine / Cove Recovery admin. And then go to my password manager, copy my password out. And after a second attempt and me accepting security certificates, I was able to get that to finally take. Let's move a little bit forward here because it did take me a good 2 or 3 minutes to actually get connected the first time. So let's see. Here we go. Remote desktop connection. Do I trust the connection? View the certificates added into the local repository so I don't have to deal with that again. And then once I'm on the machine, then I can go through and do a few things. My first one was to copy the recovery location installer from my local downloads directory into a folder on the system. This was just a quick copy and paste, but once again, PowerShell script to download it directly onto the system and run it makes a lot more sense to me. So I'll be pursuing that and adding that to our automation cookbook and my prototype section under GitHub. So recovery location, recovery service is installing. Once again, don't rename this. The structure here is unique to the installer, and if it's any name changes, it'll break that installer and not align properly. And it is a single installation or single use, so you can throw it away after you've done the install. You would never reuse this installer again. So that's all this installation is. I didn't do any additional configuration here. Once again, I'm following the steps in the documentation. It has me go off and perform another task, although technically I could have came down to my file explorer and created a couple of directories that are going to be needed for later, but I'll come back to that just to keep in context with the documented process. The next thing it asked me to do was to, let's see, set the recovery location AV exclusions. This one's pretty easy, pretty straightforward if you've ever added exclusions into Windows Defender. Don't take this one as a must-have though. So quick search here for Defender. We'll go into the AV settings for virus and threat protection. Always takes me a second to find this and remember where it's at. On down a little bit, virus and threat protection settings. There we go. Add or remove exclusions. So you're going to enter exclusions in here. You notice I've got wildcards in the paths here a little bit, and that is to account for the fact that we put the version number of the recovery agent in the path. So we're utilizing that. Adding those in though is going to potentially give you up to like a 3x increase in performance because we're not going to have scanning of all the data I'm restoring. We're not going to have the extra disk I/O, CPU overhead, and RAM utilization wants to do that extra layer of scanning. This is only going to be useful though if you trust what you're restoring. You trust that it is virus-free, that it was scanned on the upload and the original protection, and that you don't need it during the recovery process. If you have any reason to suspect it, then I would not have those exclusions set. That way you could properly scan the data as it's coming down and building out those new Azure virtual machines. Anybody wants to argue on that one, pros or cons of doing that, feel free to drop it in the question section. I'll be happy to comment on it or take it offline with you if you like. Once again, just a matter of whether you trust what you have protected previously when you go to do the restore for it. But the disk I/O impact and the RAM and CPU impact is very real. Next step is to go in, set up the recovery locations configuration for where the metadata path is going to write to. This could have been done a little bit earlier. If I were rewriting your documentation, I probably would have this happen a little bit earlier in the process. Or once again, if I do a PowerShell deploy, then I would configure this information via PowerShell so that I don't have to go back and touch the environment. Once again, this is something you're going to set up one time for your recovery service, recovery location. It's not something you're going to be setting up a lot of. So the way this is going to work is we're going to come back into the Cove Management Console. We'll go down to recovery locations. And you'll notice that recovery service that we just installed is now showing up here, but it requires a little bit of additional configuration. It needs a storage path, a place to store virtual machines or to store metadata when we're dealing with Azure. So we just hit that configure, and we come down here to this storage location, and we enter a default local path for its metadata. I'm going to go with C/SBI. While I'm in here, I can adjust the parallel restore settings or change some of the names around and things like that if I wanted to. Now, me creating the directory here or me entering the directory here does not create the directory on the local machine. So that's the reason I got to then, after I hit save here, and I waited here a little bit long, waiting for a pop-up that I didn't notice in the upper right-hand corner. But eventually you are going to want to pop yourself back over into the system, go to that C drive and actually add in that C/SBI directory or whatever default directory you choose. Once again, excellent candidate for a single PowerShell script to do all of that. Now that this guy is configured, you can see all of the stats and information for it. It's ready to set it up as a target, I do believe. Everything we've done up to this point has been, to utilize a recovery test for an infrastructure that we already have configured, or to to build out a environment where we can do recovery testing and configuration. I didn't tell you how to build up a Hyper-V server. You guys should all know how to do that. Azure, though, is a bit newer for a lot of folks, so I wanted to go through that process at a high level at least. The reason we do standby image is because it's proactive recovery. It means when the customer calls, you've already got an offline VM sitting there ready that can be booted up. We start by first synthesizing the virtual machine from your file system and your system state backup, just like we do with a bare metal recovery or a virtual disaster recovery or anything with a recovery console tied to a VDR. We apply Delta updates and Delta deletions to that offline VM. So effectively, it's a mirror or a replica of your production system. If you're using a Hyper-V system or Azure, then we're going to register the VM with a hypervisor. Otherwise, it's just a flat VHDX on local disk or on SMB3 storage. And then we can do periodic booting, once again, depending on the hypervisor and whether it is a bootable environment, so that you can get those screenshots and that proof of life. But the beneficial here is proactive recovery. This is how I would compete with, say, a Datto appliance or a Veeam sandbox environment or a Veeam quick start, I think they call it, by having these standby systems that are ready to boot at a moment's notice. It's just a matter of being proactive where you need it for that line of business application, or that 3 or 5% of the machines in an organization that needs this kind of availability. Whereas most rank and file laptops and other systems may not need this level of availability, and they wouldn't be a candidate for like a Veeam appliance or a Unitrends appliance or a Datto or something like that anyway because of the extra expense. Here, one tool, you could be reactive when you need it. You could be proactive when you need it. So let's add a couple devices into standby image to have them set up for continuous restore and maintain that offline virtual machine, both in both in Azure and in Hyper-V. So we'll start here once again in the dashboard. Let's select a couple machines that we'll do standby image for. So we go to standby image. I've already got one system here, this 2019-01 machine. We could hit the button to add to plan and pick Hyper-V or Azure here and add devices into that particular recovery location. Or I can come back out to my main dashboard and just pick a couple of devices here, looking at the list of servers and workstations that I have, and hit add to recovery plan. That'll give me the same workflow. Here we can see Azure or Hyper-V. So yeah, I guess we'll just go with 2 and 4 here. I don't necessarily know if they're assigned to something else right now or not, but we'll see whether they're compatible or whether they can be used here in just a minute. So we'll start out with Hyper-V. Pick the customer. Pick the recovery location. That's the IV server, my local Hyper-V machine I showed you guys. It's currently got one machine assigned to it. It's using 2.7 of the 8 terabytes, so we've got plenty of resources for this machine. Go ahead and hit next. Of those two devices, one's already in a plan. It's in the it's in the recovery testing plan. So I can't add it into a standby image without first taking it out of recovery testing. So that drops it out of the running. This one machine's remaining, and we can configure that to build it as a Hyper-V registered virtual machine or just as a local VHDX without a VM config file. And it's going to create that in a unique container under the HSBI directory. Various optional settings, much like the recovery console. Do I boot it afterwards and take a screenshot? Do I define the number of CPU cores, the number of gigs of RAM for the system, default subnet paths, gateways, things like that. So when I do bring it up, is it going to connect? If you're going to use a virtual switch, an isolated defined a NAT or a VLAN, you would drop that in here. And it's free-form entry as far as the name of the switch or the virtual network adapter. So make sure you get that correct by looking at your hypervisor when you type it in here. There is no validation on it at this point. Now, if I was doing multiple devices, I could apply these settings to multiple devices and then go back and cycle through them and just change individual little settings to save me several steps. If I just went local VHD, there's a lot less settings to configure here. Is there a local speed vault? Do I mark the domain controller as authoritative if there's DFS or file replication services on the machine? So anywhere you see the little I information bubble, worth mousing over it once or twice just to understand what a feature or a function does. But for this machine, we'll do Hyper-V. We'll turn this off. I'll have it boot and take a screenshot. I'm not using a speed vault. 4 gigs and 4 cores are more than sufficient. I'm not going to specify the switch right now. I'll configure that in my hypervisor when I actually go to boot it and use it in production. I'm going to set up an email address for my notification reports or my successful boots using plus notation here. So it'll go to my corporate email address, but it'll have a custom email too, so I could sort and filter on that one or, drop that to my spam folder, things like that. Now you could apply this to multiple devices at the same time if they were all being configured. And you can also manually configure individual email addresses for each machine if you're having them go directly to your end customer. Last step, it gets assigned to the plan, and we finish, and that's now going to show up in my standby image category. Now, it's scheduled. It hasn't ran yet. It's scheduled. And just because we configured it doesn't mean it's going to run right now. It could be 5 minutes, it could be 15 minutes, it could be a few hours even before that kicks off, depending on what kind of load is going on right now. If we turn on additional columns in this UI here, we can see there's probably, 34, 36 columns of information that you can get different details for a machine, including its running percentage and various paths and what switch is configured and things like that, last success time, number of files processed, and so on. If you want to pull this data out, you can export it from here just into a CSV or to an Excel format. The other option is you could use third-party tools like the API, or you could use things like Backup Operator to pull out recovery information. Doing standby image to Azure, same kind of workflow. We're going to pick the Azure recovery location now. No devices assigned yet. Now, because I didn't pick devices to start, I get a list of devices now that I can pick from. So I can choose compatible devices based on the compatibility column or look at the names. Here I filtered on machines starting with or containing 2019 in the name. And I can pick a couple of these to configure continuous restore or standby image for. They're automatic deployed devices. The encryption key is managed by the system, so therefore it grabs it automatically. Here's where you see a couple differences. Instead of it booting every session, like it does in a Hyper-V, here I can choose how frequently I want it to boot versus how frequently it restores. So here we'll just do a daily boot, and I could also choose to only restore the OS disk. Let's say I had a 300 gig C volume for my domain controller, and then I had an 8 terabyte data volume sitting behind it. I could restore the domain controller without restoring the data volume, and then only restore a portion of the data volume later using the backup manager. We do have to authenticate to Azure here because it's going to do these restores behind the scenes. So we'll do that authentication here. Same thing we do with our M365 backups and restores. And let's see. Now I'm going to be presented with some settings. Instead of it asking me for 4 CPUs and 4 cores and setting up network paths, I get more of an Azure specific window here. So what subscription, what resource group, what's the name of the virtual machine that I'm going to create? I could keep the same name as the original virtual machine, but I prefer to put a prefix or a postfix on there to designate that it's standby image. So I'll do a SBI hyphen in front of the machine name to designate it's a standby image copy, not the production copy. And I get to pick the VM that I want to use, so the VM size that I want to use for this restore. Whatever it's building will, from a virtual disk perspective, will be attached to these various virtual machine sizes. This is a great place to go check your documentation, hop on the Azure website and see how much per hour for these running machines, what are the costs and configurations limitations are involved. We don't give any more information than this based on these configs. I actually ran into a gotcha here also that you guys might see. It has to do around quotas for number of virtual CPU utilization. So I went through and tried to pick a machine that I thought might be appropriate for this underlying VM, like a 2-core, 4 gig, 2 gig core, 8 gig machine, just something fairly small, probably not that expensive. I was guessing because I can't really see prices here. And I picked wrong. But I don't really know that just yet. We'll do some validation here in a minute, though, and you'll see that. So I went from standard HDD to premium SSD disk. Figure that it's a lab environment, and I'm paying for it anyway. Why not spend a little bit more and actually get this thing restored as fast as possible by having faster I/O and faster disks. And I did assign a network a security group to this and a public IP. So that way, if I want to connect to it via RDP, I can do that. Once again, adhere to your corporate security policies as you rely on for building on Azure VMs. If you don't have policies around that one, don't build it until you do. You want to understand Azure security before you start opening up things to the world on RDP. And once again, if anybody wants to argue that one, please convince me otherwise in the question section. Okay. This is where it failed. I'm going to pause it right here. I configured it, and it tells me that this standard family quota is exceeded. Well, that's interesting. I didn't realize I had a quota for that configuration or family, but currently the limit's 0, and current usage is 0, and I need 2 in order to configure this for this process. So I clicked the link. I don't know where to go find this or where to change it. This is a new thing to me, and we don't really talk about this in our documentation as well, probably because we give it to you as a warning or an error message in the UI. But it took me a little bit of manipulation and a little bit of figuring out here, reading the linked documentation, which explains the tiering and the considerations and things like that, and then coming back in to my environment and searching for quotas, going into the compute quotas. Let's see. Going into the compute quotas here and seeing what my current quotas were and what was currently utilized. This has apparently burnt a couple other partners that told me they ran into this on their initial testing as well. So it looks like we're using 4 of the 10 available for total right now, but that leaves 6, so that should be fine. Just that the image I chose apparently is throttled at some point, and usage is of 0 right now. So I played with that for a good 5 minutes. I won't bore you with all the details on it, but I did ultimately figure out how to settle for a configuration that was appropriate. I didn't adjust my quotas. I just picked a VM size that was within an existing quota that I was allowed. And as soon as I did that, my error message goes away. It allows me to proceed with this. So it wants an email address. I use a different structure here than I did for my Hyper-V, and we'll pull up some samples here in a second. And once again, I can apply this to all devices. I can skip this step if I don't want the emails to happen and I only want to see them in the console, that kind of thing. but that's here. So that's been added successfully to the standby image plan. And we'll go ahead and finish this guy. And this guy's scheduled also. So there's no point here with me refreshing this one or sitting here and waiting for these to launch. They're going to launch when they're good and ready. Within 5 to 15 minutes, it has to check in, has to be in the queue properly, and nothing else staged in front of it and things like that. So there is no force run now for standby image. It's going to pick up with, like I said, within the next 5 to 15 minutes, maybe as much as an hour before we see that start to kick in and proceed. So let's take that a little bit further. There's one more restore type I want to get. We've got about 10 minutes before the top of the hour here. So I want to get through figuring off one-time restores for Azure using that same exact recovery environment. We'll do that in parallel. I'll show you the final results. I'll show you the screenshots that we got on the completions and everything too, so that you can see that kind of information. Once again, this doesn't replace you guys doing this and getting yourself familiar and having a location you can play with and things of that nature. Take advantage of the free Azure credit for the Microsoft Gold and Microsoft Partners. Sign up for a free trial and get your free monthly credit that way. Unique email addresses. If you've already done a trial in the past, find a unique email address to utilize for it, things like that. So for a one-time restore, why would I do a one-time restore? Well, one-time restore is going to be when you hit with ransomware and you need to restore not the most recent session, but you want to go to a session that was 5 days ago at 3:33 p.m. before the ransom attack happened. And you could use that to roll back an existing VM that's sitting out there or to build a new VM as of that specific point in time. The workflow, though, very, very similar. Let's see. So starting here, once again, in the console, I've got a couple machines selected. I go to one-time restore now. One of the differences, one-time restore is not a chargeable feature from a code perspective, whereas standby image and recovery testing are. One-time restores are not a billable or chargeable component inside of Cove. Obviously, you'll still be paying the Azure costs for this, but wanted to point that out. So we've got two devices. We're going to, instead of hitting add to recovery plan, we're going to hit this one-time restore button or one-time restore option at the top menu up there. And because I picked two machines, it's going to try to restore both machines and allow me to configure both machines. I'm going to use my default HEH computer environment, pick the default Azure recovery service. So the same one I'm just configured continuous restore for. I'm now going to do an on-demand restore. Here are my two machines. They're both compatible. That's great. It detected the passphrase. That's great. Now, had it not, or were I not a security officer, it would prompt me for the encryption key. I'm going to pause it here for just a second. The important things, the ability to pick the backup session time and date for the recovery means that I can roll back an installation to a previous point in time, or I can create a new VM that's as of a particular point in time. So we'll go back to the 25th and 26th, respectively, for these two machines. And if there were multiple sessions during the day, I could pick that session here also. I choose whether I want to start backing up the recovered VM immediately or not. And am I going to restore the OS disk only, or am I restoring the entire machine back to that Azure environment? I do have to connect to Azure. Now, I entered that information just a little bit ago, so it's still connected. If that was the wrong credential, I'd have to disconnect, reconnect. Same virtual machine settings, so I already know where I'm restoring to, and then VM size, I'll go pick the same VM instance or VM size that I chose last time, or pretty close to that. Could we do a better job here, maybe, of moving these around, sorting these, organizing these, putting some of the logic or definitions behind them that Microsoft is using? Probably yes. But you can't find it all on the Microsoft network. So then the question is, after I've restored, do I stop the target VM after the recovery? So it's going to be there and it's going to boot. Do I want it shut down? And do I want to assign a network security group for it and a public-facing IP for RDP access? So I can apply this to all devices right here, which means the settings I've chosen, obviously not the virtual machine name, but the other settings I've chosen are going to be applied to any other devices that I'm restoring, and that could be 50 or even or more that you're configuring at one time. So there's definitely some added value there. I moved forward and I get to enter the email address, but I didn't rename the second machine, so I'm going to go back and I can use this little arrow in the upper right corner up here to go to the next device. So that allows me to scroll back and forth between my machines and adjust individual settings on individual machine devices as well. So I've just put that OT for one time in front of the device name. This way I know which of my VMs are one-time restores and which of them are standby image restores doing continuous updates in my Azure infrastructure. Email address, we'll put another unique one in here just to ensure that I don't mistake one email address for a system as being from another. If these are going to your PSA and your PSA could parse the from address, you could do some creative stuff here as well. So starting restore. Restore is started. And so these, unlike standby image, are going to start immediately. So we'll see that progress, or start to see that progress in the UI here very, very shortly. Let's see where we are. I did pop out. We see in the dashboard here, we were at one-time restore. We see those. We got the columns. There's only 14 columns for this particular restore type, so those are all on by default. They can be exported out into CSV. We can use APIs to call these as well if we need them. We see the recovery started at. I don't have a progress yet, though. This progress bar, which is blank, will start to populate. I'm going to show off some examples of that in there. There was a question a little bit earlier on that asked me, how do I add a device to multiple recovery plans? Well, we've done that now. Add it to one recovery plan, come back in, configure the device again, then add it to a second recovery plan on a different Hyper-V, or add it to a recovery plan on an Azure, and then it'll exist in the system twice. If you come in and look at the device itself, and you come in here and go to settings, what you'll be able to see is here's my recovery testing monthly in this configuration. Or you would see Azure standby image and Hyper-V standby image inside of there. Here looking at my recovery locations, I'm going to go back a little bit. I can see I've got one assigned device for continuous restore here. The standby, the on-demand restores aren't showing up here because they're not assigned continuous restore devices. If I come in and look at my settings, I can see what's configured here. My history tab, I'll see my restores that have been started. So you can see these different machines doing their started restores from a recovery perspective. Sorted and filtered, searchable as well. If I go to recovery locations, let's see, that's history. Did I duplicate that one? I think I did duplicate that one. I'm looking for another piece of information here. Bear with me a second. One-time restores, here we go. So then we can see the progress now after we've let those run for a few minutes. I think the actual restore only took about 18 minutes to do these. But it gives me the ability to see that progress here, a quick refresh, and I'd watch that increase or grow if it's restoring at a fairly decent speed. Managing costs, there is a section in Azure where you can come in and do cost analysis after you've had this run for a little while to see what your costs are going to look like over an estimated time. There are cost calculators as well inside of here that can be utilized. I really can't tell you what your spend is going to be, though. This is also one of the reasons I recommend it not be your Azure account, it be your customer's Azure account, that you aren't stuck in the middle of it being paid. Once the customer's running inside of your Azure, getting them off it onto theirs could be a much harder prospect. But utilize these cost analyses here. It'll show you your current usage and then where things are going to go. And you can also set up budgets inside of Azure. And the budgets allow you to set a maximum monthly or annual spend and then alert you as you reach certain milestones in that one. So you can either ask for more money, tailor things back a little bit, change resource groups. You might look at shutting down the recovery location that's doing the restores. If it's not running 24/7 doing restores, if it's only running 3 hours a night to do the 3 or 4 parallel restores that are happening, and then it doesn't need to be ran for more than an hour, then you could automate shutting it down and starting it a couple times a day. A couple different times a day. Start it up, let it run for an hour, and then shut it back down if it's idle. Things of that nature. That way, you're not paying the compute charge. You still be paying the storage that's being used, but you wouldn't be paying the compute charge for it. Once again, mileage may vary. Objects are closer than they may appear, kind of mentality there too. So don't abuse it to start. Be very cautious on the VMs you create. Try to balance cost with price, those kind of things. But once again, this is operational expense, not capital expense. So that is good for some customers. Let's see, I need to go to a couple screenshots that I have. So here's my email from 6:23 a.m. this morning. This was Cove Data Protection. Recovery for 2019-04 of Backup Nerd Lab is complete. Recovery plan was Hyper-V, standby image to Hyper-V, completed, automated report, device name, machine name, server, operating system, status, storage path, completed, screenshot, data sources restored. So we get that proof of life here in your inbox. Let's see, I think I have another one of these. Okay, that was recovery 4. Recovery 4 and restore 2. So it's my Hyper-V. Here's my Azure environment, 2019-04. 2019-04. So 2 different reports, different sessions, one going into Azure, one going into Hyper-V. But that deliverable right there, drop those into a email folder. That is your historic proof of life around automated recovery testing for that cyber insurance policy, or that customer that's coming back to you now, questioning, well, what have you done for me lately? Well, we're testing these. Let's see, guys. I think that's really all that I have today for you. And I am going to let everybody get back to their day. Thank you all so much for coming in and laboring through 2 hours of me on recovery. It's a little sexier than backup, I know, but could definitely put you to sleep at the end of the day. So upcoming training and events, the QR code is here. The link is in the handout as well. Also blog articles and other items available here. QR code handout has that link for you guys as well. Thank you, everyone. I look forward to seeing you in the upcoming boot camp, or here in 2 weeks for our next office hour session. Take care and have a great day.